Hello. This presentation is going to review some additional facts regarding nutrition in the infant, child, and adolescent populations. Dietary patterns in the United States. Now, this is an older statistic, 2008, but this cross-sectional survey of the daily intakes of toddlers, 12 to 23 months in preschoolers, 24 to 47 months in the United States. It had an N of over 3,200. Most met their nutritional needs. Many are consuming trans fat, added sugar, and sweetened beverages. Poorly followed. So let's look further on in this. All right, so a quarter of all toddlers are not getting any fruits on a given day, and no discrete servings of vegetables. After 12 months, the dietary habits really change. French fries, fried potatoes, most common vegetable consumed by toddlers. And a third of preschoolers are consuming whole milk. Between 60 and 80% and 85% of preschoolers consume some type of sweetened beverage, dessert, sweet, or salty snack. Now, food nourishes the body by supplying nutrients and calories to function in three different ways. It provides energy. It provides the building blocks for maintaining body tissue, and it regulates body processes. Nutrients necessary for the body are classified as macronutrients, micronutrients, and water. Macronutrients are carbohydrates, proteins, and fats, and they provide calories needed to produce energy in the human body. And you go back and you think about the Krebs cycle and ATP and all of that stuff. That's where they get what they need to produce that energy. Alcohol is considered a macronutrient. Energy is 7 calories a gram. A 1-ounce shot, 80 to 90 calories. It's not required for any physiologic process. So they call that empty calories. A carbohydrate is found mostly in plants and milk. It's considered the body's main source of energy. And about 365 grams is stored as glycogen in the liver and muscle tissues. It provides enough energy for only 13 hours of moderate activity. So this is a nutrient that needs to be replenished fairly often. Too much is stored as excess fat in the fatty tissues, and it's recommended that the carb content be 50% of total calories, no less than 100 grams per day. And it serves major functions in vital organs like the liver. It spares protein for energy and participates in specific detoxifying metabolic pathways, and the heart as glycogen stored in cardiac muscle, and the central nervous system as the only energy source to the brain. So carbohydrates are very important, especially in brain development of children. All right, carbohydrates, main dietary source of energy. It should provide 45 to 65% of energy requirements. Simple carbs are sucrose, fructose, and lactose. Complex are grains, legumes, and vegetables. And if carbs are limited in the body will break down stored fats and protein for energies, resulting in the elevation of ketones in the body. Refined foods should be limited, including white flour, white sugar, white rice, and corn syrup. Now let's look at proteins. The major function of protein are as follows. It builds and maintains tissues, regulates internal water acid-base balances, acts as a precursor for enzymes, antibodies, and several hormones. If more protein is eaten than is needed, the surplus is used to supply energy and stored as body fat. It's present in all animal and plant products, is essential to life, and part of more than half the organic matter in the body. 20 different amino acids combine in different ways to form proteins, and 9 are essential. They cannot be manufactured by the body, and they are essential for normal growth and development. So they have to be taken in. They're not produced. Preterm infants require more protein than term. Nitrogen is a component of amino acids, and conditions of extreme stress and disease can deplete nitrogen, which require additional protein demand. Nitrogen input and losses can be used to study protein metabolism. Sources of nitrogen include meat, dairy, eggs, nuts, legumes, grains, and cereal. And we lose nitrogen through urine, feces, sweat, hair, and skin, burns, fevers, hyperthyroidism, wasting diseases, and during periods of fasting. Now, this slide illustrates some proteins obtained through nutrition, and you can see the essential amino acids. These are amino acids that are required by the body, but not produced by the body. All right, so complete proteins versus incomplete. Complete proteins contain enough of all 9 essential amino acids. Incomplete proteins are foods that lack one or more of those essentials. So complete proteins versus incomplete. So let's look at these. Complete proteins include whey, casein, milk, eggs, beef, cheese, chicken, fish, yogurt, cottage cheese, and turkey. Incomplete: vegetables, fruits, rice, grains, oats, pasta, nuts, bread, and sunflower seeds. Incomplete proteins don't support cell growth. They lack one or more amino acids, and they are found in plants, and but they can be mixed together to make a complete protein. Incomplete plus incomplete may equal a complete. So grains, cereals, nuts, or seeds eaten together with dried beans, for example, lentils, peanuts, or peanut butter make a complete protein. Like peanut butter on wheat bread, rice and beans, split pea soup with cornbread. All of those things can be combined to make a complete protein. Macaroni and cheese and tuna noodle casserole. And here are protein complements. So these things combined together create a complete protein. Now let's look at the recommendations. Protein content of the diet: 14% to 20% of total calories, or a daily minimum of 13 grams in infants, 25 grams in children, and 45 grams in adults. We want to choose lean meats, low fat or fat free, and 65 to 70% of protein should come from complement proteins. And the American Heart recommends 2 servings of fish a week, not commercially prepared fried. It can be high in trans fats or low in omega-3, so not that. Children are to eat 8 to 12 ounces of fish per week, low in mercury, like shrimp, crab, clam, salmon, pollock, tilapia, catfish, and cod. A can of light tuna, 4 ounces a week, and we want to avoid albacore tuna. Now, fats. Fats include lipids, fats, and fatty acids. They provide energy and are essential for the absorption of fat-soluble vitamins A, D, E, and K. Maintains the integrity of the cell wall and the myelin sheath. Other major functions include synthesis and regulation of hormones, maintenance of tissue structures, nerve impulse transmission, memory storage, energy metabolism. But if excess fat is consumed, it's stored in fatty tissues in the body. So there's a theme here, right? With proteins, fats, and carbohydrates. If they are taken in the excess, they are all stored as fat. Now, we have essential fatty acids, and there are 2 not produced by the body. Precursors of omega-3 and 6 fatty acids, we can find them in flaxseed, walnuts, canola oil, and wheat germ. Linoleic acid or omega-7 fatty acids and alpha linoleic acid or omega-3s. Fatty acids are essential for normal growth and development. Fat under the skin and around the abdominal organs serves purposes to reserve or store fuel, support and protect organs, and prevent undue loss of heat. And the daily recommendation of fat is 25 to 35% of your total calories, at least 20 to 35 grams of fat per day. All right, so less than 2 years of age, there's no restriction on fat, and whole milk is recommended as long as there's no obesity. Why? Because we need that whole milk to promote brain development. Over 30% maximum, 20% minimum calories from fat. Over the age of 3, saturated fats and cholesterol in diets are not necessary and should be minimized. Trans fatty acids should be at 0, and that's fatty foods, fried foods, fast foods, baked good industries, often found in foods that have a prolonged shelf life. Now, trans fat and trans unsaturated fatty acids, we want to avoid those. These are a type of unsaturated fat commonly produced in industrial form, like margarine, snack food, packaged baked goods, and frying fast food. This was begun in the 50s, and it's associated with an increased risk for coronary heart disease. It raises your LDL, lowers your HDL, and increases your triglycerides. Micronutrients. These are substances that are required and stored in very small quantities by the body. And this includes vitamins, minerals, electrolytes. They're not used as a source of energy, but are essential for growth, development, and hundreds of metabolic processes that occur daily. Micronutrients include vitamin and minerals, and they have to be taken by food or supplement. Micronutrients cannot be metabolized by the body except vitamin K and biotin. These are produced by certain intestinal microorganisms. And vitamin D is synthesized from cholesterol. Niacin is synthesized from tryptophan. Let's look at fat-soluble vitamins like A, D, E, and K. They're stored in body tissues for a long period of time, absorbed in the intestines along with fat and lipid foods. Intestinal motility problems or malabsorption can cause deficiencies in these vitamins, and they're fairly stable when heated. Fat-soluble vitamins require bile for their absorption. Now, water-soluble vitamins like C and B complex, they're stored in small amounts. If the intake exceeds the need, the body will excrete the excess. Taking these daily is required, and the B vitamins contain nitrogen and serve as essential coenzymes in the body's metabolism of nutrients. Minerals and elements. Major minerals found in the body in amounts of greater than 5 grams are calcium, phosphorus, and magnesium. Peak bone density is related to the calcium intake during the years of bone mineralization, and typically that occurs before the age of 20. Children are at risk for iron deficiency during periods of rapid growth combined with low dietary iron intake, 6 months to 4 years, early adolescence, and adolescent girls. So let's look at this dietary reference intake of selected nutrients for infants and how they vary from 0 to 6 months and from 7 to 12 months. Water is the most vital nutrient. The adult body is anywhere from 55 to 65% water. Infant and children's bodies are 75% water, and seniors 45%. An individual can exist without food for several weeks, but without water, an individual will only last a few days. Water provides turgor to body tissues and alters the configuration of substances for the metabolic process. It transports body nutrients and waste and maintains a stable body temperature. There is a continual loss of water through the body by the kidneys as urine, the lungs as water vapor expired, and skin as perspiration. We lose about 2 to 2.5 liters of water every day, which are replaced by fluid intake, by water contained in the solid foods that we eat, and water produced in the body as a result of the oxidative process. All right, so there is no research to identify exactly how much water you need to drink, but typically we say 6 to 8 8-ounce glasses of water a day. I like to gauge it by the color of urine, so your urine should be lightly yellow. And it is possible to drink too much. Kidneys are unable to excrete that excess water. And if you drink too much water, the electrolyte content of the blood is diluted and it can result in hyponatremia. And actually, it is called water intoxication, and it can result in death. Now, sometimes you need to drink that excess water when you're exercising, hot or humid weather, or if you're at higher altitudes, you need to take in more water. Illness or health problems, pregnancy or breastfeeding, all of those things, you need to drink more water. So when you are taking a nutritional assessment of your patient, be it a newborn, child, adolescent, or an adult, you need to carefully listen and take a thorough history. And with infants and children who don't have a voice of their own, it's important to have a caretaker that is a reliable historian. Your physical exam can elicit many clues to identify whether or not you believe that the patient is in a good nutritional state, and lab tests can also identify if there are any deficits or excesses where nutrition is concerned. I hope that you found this presentation helpful, and have a good day.